Please.
Yeah.
Are we ready?
Yep.
Hi, everyone. Welcome to our talk on the fact that no one likes crashing or janky apps. I'm Lydia. I'm a technical program manager on Android.
And I'm Ricardo, engineering manager on Google Play.
Hey everyone, Fergus, product manager for Android Vitals. Hands up here who likes 1-star ratings. OK, we got one person who's in the wrong talk. I'm sorry, but the people who don't like 1-star ratings are in the right place. So we're here to tell you how you can engineer your app for high performance with the new tools available on Android and on Google Play. We're going to start off by talking about why performance matters in general. And then we're going to jump into the new initiative that we have around Android Vitals and how we've simplified it for you to be able to understand and take action much easier by using the concept of bad behaviors. Then we're going to jump into how you can detect and fix these issues most effectively to be able to have a successful app. Great. So for the people who want to avoid those 1-star ratings, the #1 way you can do that is by focusing on stability of your applications. We put Google's machine learning to work to be able to figure out what are people talking about in 1-star ratings. And we found that 50% of 1-star ratings are talking about stability and bugs. Then, once you've fixed those issues, how can you get to a 5-star app? What we found is that if you want to get to a 5-star app, focusing on design, usability, and speed are the things that matter, because 60% of 5-star reviews are talking about those topics. But don't just take our word for it, or more likely Google's machine learning words for it. You need to actually take developers' words for it. The Busuu team, which has built an amazing language learning app, found that by focusing on performance and making that a part of their culture, they were able to increase their star rating as a result. The Big Fish Games team have even seen increases in retention by focusing on performance. At Google, and specifically within Android, we're obsessed with app performance and device performance. We've been obsessing over this for a number of years now. Back in 2012, we launched Project Butter with Jelly Bean. Since then, we've launched the Doze mode, Project Vulkan last year, and this year, a bunch of new tools in Android O, and the ability for you to be able to get insights with Android Vitals. So what is Android Vitals? You might have seen this in the keynote earlier today. This is our new initiative to be able to help you be able to gain deeper insights into the performance of your application across core performance metrics. The 3 that we're starting with are stability, battery, and render times. You'll see many more come over the course of the next few months, and we'll be able to give you those insights on Android and on the Play console. So let's jump into the 3 that we're launching today. First one is stability. So everyone knows that you shouldn't have your app crash. People have been focused on this for a number of years. And Crashlytics has introduced the concept of crash-free users. Now in the Play console, you can be able to see your crash-free user rate and your crash rate. You can also be able to see your ANR rate. And this is where your ANR is a concept on Android, which is application not responding. That's when your app appears frozen and does not respond for 5 seconds. The next area is battery. So this is where we want you to avoid using people's devices and consuming their battery inefficiently. So this is where we want to avoid using the radios or using the CPU when you shouldn't be and you don't need to actually. The next area is rendering. So this is where we want to be able to help you understand how can you provide a silky smooth experience to your users so that they feel like your app is smooth and fluid on their device. And we've 2 metrics that we're going to introduce to you today that can actually help you be able to deeply understand that area. So we're talking about 3 major performance areas here. And within each performance area, we're going to be introducing 2 metrics. It's a lot of data to be able to understand and consume. So we've simplified it to this concept of bad behaviors. This is where we take your app and we study the performance data on it, and we figure out if you're in the bottom 25% of apps according to that metric, we flag it to you and say, hey, you need to improve in this area. let's do a show of hands. So if, let's say, 5% of your users are experiencing that 50% of their frames are taking more than 16 frames per 16 milliseconds to render on the screen, is that a problem? Hands up if they think it's a problem. OK, great. So lots of people agree that's a problem, and lots of people don't agree that that's a problem. Well, we will actually tell you in the console when you've reached the boundary of when that's a problem and you're in the bottom 25%. Right now, that's at about 2% of users experiencing that rate will actually be flagged, and that is putting you in the bottom 25%. So we're really trying to simplify it there for you, so you can be able to understand where you are positioned according to the benchmark. So where do you see this data? You see this data in a new top-level navigation item in the Play console called Android Vitals. It's live right now to all of you, and if you have enough data, you'll see the insights that I'm talking about and that Ricardo is going to tell you more about right now.
Thank you, Fergus. So as Fergus just said, we just launched a new section in the Play console, which is called Android Vitals. And this is available to all of you today, and you can go and check it out now. What it does, it summarizes all the findings that we have about your app performance across these 3 domains that Fergus just mentioned: stability, battery, and rendering. It works out of the box without any integration needed. No SDKs to add, nothing to add to your APK size. The data that you find there is collected from millions of Android users that have opted in to share diagnostic information with Google to help all of you understand and improve the quality of your apps. Android Vitals also highlights whenever at any given time there is a problem that affects a significant fraction of your users. For example, you can see one of the red marks over there to indicate that you should be looking at your rendering and understand if there is an issue there. And so you can use this as the first port of call to understand your application performance. So we're going to spend some time now to go into detail about all these 3 domains: stability, battery, and rendering. I'm going to start with stability. Stability is about crashes and ANR reports, applications not responding. Until today, the only way for an ANR or a crash to surface in the Play console was if your users explicitly acknowledge a dialog on the phone for each ANR and crash to be reported. And this is obviously tedious, and it led to low volume of crash and ANR reports. So the first thing that we have done with Android Vitals, we have greatly reduced user friction. As I mentioned, the data that you find there comes from users that have opted in to share diagnostic information. Opt-in typically happens only once when a person activates a new phone, and that is a very low friction gesture. So this means that in the Play console, now you see over 100-fold coverage in the number of reports, with reports coming from users running versions of Android as old as Jelly Bean. And this reaches 98% of the Android devices that have Play services installed. So let's start with the first domain, stability. What are the bad behaviors that we want to flag out there? Crashes and application not responding, which is application freezes. For sure, you never really want any user of your app to experience one of them. And so we define these bad behaviors in terms of percentage of users that are experiencing any of them in any given day. You may be familiar with the equivalent metric that other crash reporting tools have introduced, crash-free users. And so for the next few minutes, I'm going to focus on ANR specifically. What is an ANR? ANR means application not responding. And this happens when your application freezes and stops responding to user input. This could be because you have a deadlock in your multi-threaded code, because you have a UI thread which is too slow, or because you have background receivers that do not complete within a meaningful amount of time. ANRs are super disruptive of the user experience, and therefore you should aim to never have any of them. And because the application is frozen during an ANR, it means that you cannot typically use a crash reporting SDK to collect them. On the other side, the Android platform tracks all of them automatically. So they're all available in the Play console without you having to do anything at all. You just go to the Android Vitals section, and in there you will find a tab which is called ANR Rate. Here you can see how many unique users experience an application not responding when the app was used on a given day across app versions, device, and OS versions. And if the fraction of the user is significant, you get a red highlight to drive your attention. So you can focus on the most prominent issues and dive into the details. You can click the Related ANR section, and in there, you arrive in the ANR and crashes section of the Play console. Here, in addition to reviewing your overall crash-free rate and ANR rate, you can dive into each crash and ANR that has been detected for your application. Android collects ANRs and crashes almost immediately as they occur. So here you find crashes and ANRs that are typically a few minutes old at most. There is a bunch of little new features. For example, we highlight when a given ANR has been introduced for the first time in your most recent app version with those little orange highlights to help you track the quality of your last release. You also get to see the number of unique users that have been affected by that particular ANR. So you can distinguish between high-volume issues that are affecting only a handful of users versus widespread ones that might be affecting a significant fraction of your user base. You can dive into the details and observe how the number of reports and the number of affected users trends over time. And now it breaks down across device versions, OS version, app versions. And obviously, you also get the full thread dump that captures the application state at the time the ANR occurred. And for crashes, obviously, you get similar functionality where you get the stack trace that was observed when a crash occurred. So I think this gives you a pretty good information, visibility into what is happening on your user's phone. The next step is to try and reproduce and debug them. What I recommend is the new Android Studio 3.2 that has plenty of new profiling capabilities. The new Android profilers in Studio 3.2 provide real-time data about your app's CPU, memory, and network activity. And I think this is a great next step to debug your ANRs, because root causing them often lies in not taking into proper consideration CPU-intensive operation or blocking operations like fetching data from the network. The CPU profiler, for example, gives you real-time CPU usage for your app process on a timeline. You can dive through instrumented method traces and understand which methods maybe in your UI thread are using up most of the time and become blocking. Similarly, the network profiler displays network activity on a timeline, showing the data was sent, received, and associated latencies. Again, you can use this to understand if a slow network call is making your thread blocks for a response or an because of an ANR this way. And as Steph showed in the keynote before, it's very easy from here to jump directly into the code that is responsible for that network call. If you want to learn more about the Studio Profilers, there's a great talk tomorrow morning in Amphitheater that I encourage you to go and attend to. OK, now we discussed how to review how many ANRs you have, how to debug them. But the thing is, how do you prevent them from happening in the first place? Textbook recommendation, Android 101, is do not do blocking operations in the UI thread and use, for example, a sync task instead. You can use strict mode to catch accidental disk or network access on the application main thread as well. Another common case is when you have a broadcast receiver that receives an intent and does not finish processing within a window of time, which is around 10 seconds, or your broadcast receiver goes async, but you forget to call finish on the pending result that you get back. Again, this is Android 101, very simple examples. Most likely, your code is much more complicated than this. You may be using queues, asynchronous operation, libraries like RxJava. The basics do not change. The same recommendations apply. Be mindful of on which threads the callback for your asynchronous processing end up executing on. Use semantics in your coding practices that make sure that you don't end up executing accidentally on UI threads when you don't want, and so on. Finally, be mindful of introducing deadlocks in your app. And be it because you go and check the ANR traces that you're collecting when the device is connected to your PC when you're doing debugging, or by downloading the tracing from the Play console, you can easily spot if at any time you have deadlocks by, for example, looking when a given thread, like the UI thread here, is locked, waiting for a background one, and vice versa. So this is all I had to cover about ANR. But a fundamental question remains. How much do they matter? How much should you care? And the answer is you should really care a lot. We look at the apps that have a high and low crash rates in play. High crash rate, more than 5% of users experiencing a crash or an ANR per day. And what we find is that these apps have 30% more uninstallation in the first day than apps that have a low crash rate, less than 1%. So the message is pretty simple. If your users find your app and they experience a crash, most likely they will leave as soon as they found it. I will now hand over to Lydia for battery and rendering.
Thanks, Ricardo. Android users care a lot about battery life. In fact, making it through the day without needing to charge their device is a top concern for Android users. Because of this, the Android platform has spent a lot of time building features to save battery. One of the #1 ways we can conserve power and battery power is by putting the device into a deep sleep when it's idle. This means powering down the CPU, radio, and other components that would otherwise drain power. However, you, as application developers, can prevent the device from going into a deep sleep and conserving power. One of the ways you can do this is through wake locks. Wake locks keep the device awake so that it can perform an activity on behalf of your application. There's a couple different types of wake locks. The first is a full wake lock. This keeps the screen on, and this is usually used by a video app or a gaming app. Because the screen is on, the user is going to be aware that the wake lock is being held and in full control of powering down the app and saving their battery. There's another kind of wake lock, though. This is called a partial wake lock. A partial wake lock doesn't keep the screen on. Because of this, the user doesn't know that the wake lock is being held. And so if a partial wake lock is held for too long, it can become a silent and deadly killer of battery power. Because of this, we've defined a bad behavior around stuck partial wake locks. We define a stuck partial wake lock as one that's held for over an hour by a significant percentage of your users. The Android Vitals dashboard will show you how you're using and possibly abusing wake locks. It will show you the distribution of how long wake locks are being held by each version of your app. In this example, you can see the majority of wake locks are being held for a minute or less, which is ideal from a power-saving perspective. However, there's a long tail of wake locks that are being held for over an hour, which meet our definition of bad behavior, or stuck wake locks. So you can see that we flagged this app for this bad behavior in the Android Vitals dashboard. In the Android Vitals dashboard, we'll give you the information you need to debug your stuck wake lock. Most importantly, the name of the wake lock. In order to protect user privacy, we will only show wake lock names if it's been used across many sessions. This will prevent the leaking of any personally identifiable information. Because of this, I encourage you to use standard wake lock names for each distinct wake lock in your application in order for them to be debuggable in case they become stuck wake locks. The reason that we're highlighting stuck wake locks in the Vitals dashboard is because of just how dangerous they are. I mentioned in Android, we care a lot about conserving power. So every day, we collect reports from internal Google users who have experienced a bad battery day. A bad battery day is one where your device, the battery doesn't last as long as it usually does or as long as you expect it to do. So they'll send us these reports. We did some analysis across a 2-month period of all these reports last summer, and we found that 30% of these bad battery days were caused by stuck wake locks. I think this highlights really how dangerous wake locks are. They cause real problems for real users. Because of this, I encourage you to avoid using wake locks entirely. Wake locks were introduced in the early days of the Android platform. And since then, many of the use cases for which you needed a wake lock, you no longer need a wake lock for. For example, if you're doing a long-running download, you can use the download manager instead. If you're synchronizing data with an external server, use the sync adapter instead. If you need to run a background task, use the job dispatcher. And if you're holding a wake lock so that you can process an intent before the device goes to sleep, use the new job intent services, which is being released in the support lib v26 that's coming out later this quarter. Both job dispatcher and the job intent service are compatible with the background restrictions that we're going to be rolling out in O. So it's a win-win. You get a background restrictions compatible service, and you don't get any stuck wake locks. So definitely check out job intent services in support lib v26. If you're unable to use any of these alternatives and you need to use a wake lock in your application, I'll rehash some of the fundamentals from CS 101 because they're just so dangerous. I'll spend some time rehashing. First is keep the logic around your wake lock extremely simple, because any errors in the logic could lead to them getting stuck. Second, try to do as little as possible while you're holding this wake lock so that it doesn't need to run for an hour or more to do whatever operation you're holding it for. And finally, use defensive error handling. You can see in this example here, if I hadn't defended against my cleanup task throwing an exception, the release method on my wake lock would never have gotten called, and some poor user, or perhaps millions of users, would end up with dead phone batteries. So if you follow all my advice and are able to not use any wake locks in your application, I still want you to go check out the Android Vitals dashboard for stuck wake locks, because it's possible that services you depend on are using wake locks under the covers. For example, the network location provider wake lock in this case, it's used by millions of apps to find a user's location. If you're using it too aggressively, it could hold wake locks for an extended period of time that becomes stuck, and you get flagged for that. So in this case, you would fix that stuck wake lock by throttling back the amount of calls you make to this service. So definitely check out this tab, even if you're not using wake locks, so you can tune how you use the services under the covers that might be using wake locks. The second way you, as an application developer, can prevent the phone from going into deep sleep and saving power for users is through the use of Wakeups. Wakeups are alarms that you can fire outside the lifetime of your application to wake the device up to do some sort of task on behalf of your application. If you do this excessively, the device won't be able to rest, and you'll end up draining a lot of power. So we've identified a bad behavior of excessive wake-ups. We define frequent app wake-ups as a percentage of users who are impacted by wake-ups that occur more than 10 times per hour. Just like wake locks, you can get a full report on the wake-ups that you're using or possibly abusing in the Vitals dashboard. And just like wake locks, you'll see the distribution of the number of wake-ups across sessions, and you'll be able to see the names of each wake-up, so you can debug any frequent wake-up issues. And just like wake locks, we'll only show the wake-up name if it's seen across a lot of sessions, so that we don't leak any personal identifying information. So again, be sure to use a standard name for all wake-ups. A lot of people use the pattern of firing a wake-up to get the device awake, and then holding a wake lock to keep the device awake so that you can perform some sort of task. This is a double whammy of possible bad behavior, because you might be waking up the device too frequently, and your wake lock that you're holding may get stuck. So let's get rid of both of these. A much better alternative to wake-ups and wake locks is the Firebase Job Dispatcher. The Android platform itself does have a job scheduler, but I encourage you to use the Firebase Job Dispatcher because of its backward compatibility. In the Firebase Job Dispatcher, you can set up a task to run as a repeating task. For example, I can run this every 30 minutes. Dialing back the frequency that you're running the task is a first step to save some power. So 30 minutes is certainly better than running this every 5 minutes. However, you can also constrain the job to run only when it's on a charger. This is obviously the ultimate battery saver, because it would never run while the user's on battery. Here at Google, a lot of our apps employ this method. For example, Play Store will wait to auto-update apps until you're on a charger. This is because we understand a user would rather have a device that lasts through the day than a latest update of some apps. So I encourage you to use that same very critical lens when you're considering scheduling jobs. See if it can wait until the device is on a charger. The final bad behavior we'll talk about today is render times. Render times measures the amount of time a frame drawn by your application takes to actually get rendered on the screen hardware. Render time directly correlates with how users perceive the performance of your app. Android devices render at 60 frames per second. This is based on the refresh rate that's available in the screen hardware itself. If you do the math, 60 frames per second breaks down to having to render a frame every 16 milliseconds. So as long as your app is rendering a frame every 16 milliseconds, users will feel that your app is very smooth, very fluid, and very pleasant to browse. If your frames take longer than 16 milliseconds, even just 17 milliseconds, it will get dropped. If you have a lot of dropped frames, your application will feel very stuttery, very jarring to users. So you want to minimize the number of dropped frames that your application has. If you drop many frames in a row, and you get to the point that it's been 700 milliseconds before you draw the next frame in your application, this is the point at which users will think your app is unresponsive, and they'll begin to feel frustrated by it. You should aim to have 0 frames that take 700 milliseconds or more to render. We've used both of these thresholds to identify some bad behavior. The first is slow rendering. We define this bad behavior as the percentage of users who experience more than 50% dropped frames. The second bad rendering behavior are frozen frames. We define this as the percentage of users who experience more than 0.1% of their frames being frozen. The Android Vitals dashboard reports on both of these metrics and will flag you if you're excessively slow in rendering or too many frozen frames. Just like wake locks and wakeups, you can see the distribution of rendering times across sessions. And the dashboard will also give you some other statistics that help you understand what might be causing your rendering issues. For example, I can see a high percentage of slow UI thread activity. This indicates to me that I'm probably trying to do too much work on the UI thread. So I should move things like disk I/O or network activity to a background thread. These statistics, though, are pretty high level, and they'll just hint at the root cause of your rendering issues. To really understand what's causing your rendering issues, you'll need to dive deeper. You can do this in 3 steps. The first step is to instrument your app with the Frame Metrics Aggregator API. This API is built on the Frame Metrics API that was released in Android Nougat. The Frame Metrics API collects statistics about how long each frame takes to render. The Frame Metrics Aggregator API, as the name suggests, aggregates these statistics across a series of activities that you define. And you define the start and the end point of that collection. So you can collect statistics about how long specific workflows in your application take to render. Once you've done this step, step 2 is to get this data off the device and upload it to the cloud or your servers where you can then analyze it. You'll analyze it to find what flows are rendering slowly for the majority of your users. From there, you can move on to step 3, which is getting your device out, walking through those flows, all the meanwhile recording a trace. Once you've reproduced that slow rendering behavior or those frozen frames, you can upload that trace into systrace, which will tell you exactly what was going on in your application when that slow rendering occurred. And not just your application, but what was going on in the system as well. From there, you can figure out which specific code paths you need to optimize to fix your rendering performance. I've just skimmed the surface of the Frame Metrics Aggregator API as well as systrace. Luckily, you have 2 more opportunities to learn more about them. This evening, Tim Murray, who's an expert on systrace, will give a talk on how you can use it to debug rendering issues. Tim has analyzed over 1,000 systraces and is a true expert in the field. On Friday, you can go learn from Chris and Chet, the authors of the Frame Metrics Aggregator API, about how you can use it to really understand your application performance. And with that, I'll give it back to Fergus to close.
Thanks so much. Thanks, Lydia. Great. So today we introduced 3 performance areas. We have many other performance areas that we're going to be introducing, as I mentioned earlier, over the course of the next couple of months. App startup time, memory, and network use. For each one of these performance areas, we're going to introduce bad behaviors, so it's really easy to understand the metric and how you're doing in that metric compared to other apps. A lot of the tools we've talked about, especially on the Play Developer Console side for the Android Vitals dashboard, aggregate over your whole APK. If you want to understand within your APK specific performance areas, I'd encourage you to use the Firebase performance monitoring tool. It was launched earlier today at the developer keynote and enables you to be able to instrument your app. Out of the box comes network and startup time, but you'll also be able to use your own counters to be able to track whatever you would like to track in your application. There's a talk on this that's going to happen tomorrow, and I'd encourage you all to attend that to learn more about how you can be able to use the Firebase Performance Monitoring SDK in your application to be able to improve performance. So we covered a lot today. We covered why performance matters. We covered Android Vitals and introduced the new concepts around bad behaviors and the 6 bad behaviors. Again, those bad behaviors are high ANR rate, high crash rate, excessive wake-ups, stuck wake locks, slow rendering, and frozen frames. We introduced the Android Vitals dashboards in the Play console, talked about the Android Studio 3.0 profilers, and the Android APIs are available for you. So if you're not motivated by all the things we talked about around performance today, I encourage you to come to our talk tomorrow where we can give you a BuzzFeed-like talk on why you should care more about performance with all the Play console tools that we have available. So one of the things that we're going to talk about in this talk is the rewards that the Play Store is going to offer you for being able to improve the performance of your application. We'll get more into the details there, but we're going to start using this performance data in the promotability within the store. Another reason why you should care about performance is we have 2 billion users on Android right now. It's a lot of users. A lot of users are using their devices to make emergency calls. If you improve the battery life of your device and of the device itself by improving the battery life of your app, then users' device will last longer. They'll be able to make more emergency calls. And you're basically, I'm going to go out on a limb and say it, saving people's lives by focusing on performance. Great. Maybe stretching a little there, but hopefully you get it. Great. Thank you very much, everyone. I really appreciate joining today.